Okay, first let's start with the trigonometry. So here they have given, it's a Greek word, measurement of triangles. Actually, this trigonometry was derived from the word trigon and metron. Okay, trigon, measuring the sides of the triangle. That's the exact meaning of trigonometry. Okay, we are going to read about many types of triangles in trigonometry. Okay, trigon and metron. You understand? Okay, Josh. So the next one, what are the central angle of a circle? Just 1 second. I'll download this so that I can write it on the notes. Okay. Yeah, even I can write it here itself. No, I'm sorry. Yeah. Okay. Central angle of a circle. What is that central angle? These are the basic definition you should know to go inside. Okay. So that's what we are going to see now. First one is, what is the definition of trigonometry? What is a central angle? Angle whose vertex you call it to be the center of the circle. Okay, angle whose vertex is the center of the circle, that's called as a central angle of a circle. Okay, so when you are going to have a circle like this, okay, fine, George, and this is going to make an angle, means this is called as a central angle, we call it. Okay, fine. Next, what are complementary angles? Two positive angles whose sum is going to be 90-degree measurements, we call it to be the complementary angles. Okay, this I hope you would have studied in your 4th and 5th grade itself. What are your supplementary angles? Two positive angles whose sum measurement, when you add up, you should get 180 degree. Okay, what is degree? The most common unit of angle measure, denoted by the symbol. This one you call it to be the degree. Okay, fine. So if I'm going to say a measure of 1 degree is equivalent to a rotation of 1 over 360. That means a 1 complete revolution has happened. Okay, because in a circle we start from 0 and we end up with 360 degree. That's why it's 1 upon 360. Okay, yes, George, got it? Okay, 1 second. I need to move down, just 1 second. Okay, now I think. Okay, now let's go into the thing of your 1 second. Let me remove all these things. Okay. Is it okay? I will open the file here, George, because it's confusing for me. 1 second.
Sure.
Just 1 second. Let me open it here. The writing part will be easier for me. Okay, yeah. Now coming to the definition of an angle. How you are getting an angle? An angle is determined by rotating a ray, okay, half line about its endpoint. Okay, fine. You are going to rotate a particular ray about this half point, you will get an angle. Okay. Next, what is the definition of an initial side? Initial side means the starting position of one particular angle where it is formed. Okay, from here only it's starting. So this is called as an initial side, and it gets ended at this point, you call it to be the terminal side. Okay, so the position of the ray after the rotation when an angle is formed, you call it to be the terminal side. Okay, then coming to the part of what is a vertex of an angle. Vertex means it's nothing but the end point of the ray where it both the how an angle is formed. An angle is formed by joining two rays. Okay, and where the two rays meet at a common point, that common point you call it to be the vertex. Okay, you understood, George? Okay.
Yep.
Now, an angle is a standard position when the angle's vertex is the origin, okay, of a coordinate system and its initial side coincide with the positive x-axis. Standard position means when your angle's vertex will be at the origin, okay, of a coordinate system and its initial side coincides with the positive x-axis. Okay, that means like this it should be. You understand? This is the origin. This is called as a standard position. Okay, that means this initial side, okay, and this one gets coinciding with the positive x-axis. Okay, next, what is your positive angle? It's generated by a counterclockwise rotation, whereas a negative angle is generated by a clockwise rotation. Got it? Yes.
Mm-hmm.
Now, if two angles are coterminal, then they have the same initial side and same terminal side. Okay? Yes.
Mm-hmm.
Now, see this.
Can you
What?
just scroll up again? Sorry.
Yeah,
Sorry, I just
yeah,
want to get
yes.
the last part done.
Yeah, yeah. So when you say the two angles are coterminal, then they have when they have the same initial side and same terminal side. Okay, you are having two angles here. You understand? See, like this somewhat. You understand?
Okay.
Same initial
Mm-hmm.
side and same terminal side. Okay. For example, I've shown there. Okay. Yeah.
Mm-hmm.
Next, coming to your radian measure. This is very important when you go to your unit circle. Okay. So why we are introducing all these things here? If you're thorough with this, the unit circle will be easier for you. Okay. Now, the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. Obviously, how you measure your angle from your terminal side, how much it has turned tilt to your initial side to terminal side, that will measure your angle. Okay, fine. Now, what is 1 radian? 1 radian means it's a measure of a central angle theta. That means so if I'm going to have an angle in a particular circle, okay, fine. This is the vertex I'm going to have. Sorry, for example, I'm showing you. Okay, fine. So 1 radian means where your intercepts of an arc S equal in length to the radius of the circle. Okay, you understand
Mm-hmm.
this part? Okay. Next, what are central angle? Central angle of one full revolution, that means it becomes a counterclockwise there, okay, corresponds to an arc length of S, that is 2 pi r. You understand?
Mm-hmm.
Central angle of one full revolution will be 2 pi r always. Okay. Next, a full revolution of a circle of radius r will correspond to an angle of 2 pi radians. Okay. A half revolution will be pi here. Okay. Full revolution means it is 2 pi the radians, and half a revolution of that will be pi, because half means already 2 pi was there for full revolution. Half of that will be pi. You understand?
Mm-hmm.
This term. Next one. Angles with measures between 0 and pi by 2 radians will be acute angle. Okay. So 0 to pi by 2, obviously you will have 30 degree, 45 degree, 60 degree, like that. Okay. And angle measures between 90 degree and 180, that would be obtuse angles. Okay. Now, what you have to do if they are asking you to find an angle that is coterminal to a given angle theta, means you need to add or subtract 2 pi. Okay. Fine, to measure the angle of theta. For example, see this. Find an angle that is coterminal with theta equals to negative pi upon h. Okay. So what you need to do here, it is negative pi upon 8 they have given. Okay. You need to add or subtract 2 pi. Okay. To measure the angle of theta. So what you will do here? Can you guess, George?
It's 45.
Yes, right. Okay. Next one. Find the
Oh,
supplement. 1 minute. 1 minute.
yeah,
Yeah.
it's 45. Sorry.
Yeah. Find the supplement of theta equals to pi by 4.
No, no, sorry. Wait a second. It won't be 45. Actually, it'll just be 22.5.
One
But
second.
I mean, like the angle itself will be like 22.5, but the coterminal angle will be 15 pi over 8.
Yes, right.
And pi over 4, the coterminal angle. Yeah. Sorry, the supplement of pi over 4 will just be 3 pi over 4.
Yes, the first one will be approximately, I think so, 335 or something. Yeah, this one is supplement. Okay, yes, correct. Okay. Now come this. A full revolution around the circle corresponds to 360 degree. This I told you. When you have a circle, it starts with 0, 90, 180, 360. Okay. So 270, and then when it reaches again here, it becomes 360. That's why 360 degree is called as a complete angle. Okay. Next, half revolution will be 180 degree. Okay. This one. Got it? Yes, George? Mm-hmm. Now, next one. To convert degree to radians, this is very important. You will get many problems based on that. When they are giving a degree and they're asking you to convert it into radian, okay, you multiply that degree by 180 degree. Okay, fine.
Mm-hmm.
So pi radians, you are going to multiply it by 180 degree. Okay. To convert your radians to degree, you need to multiply your radians by 180 degree. That's the thing. Okay, got it?
Mm-hmm.
So now convert 120 degree to radians. They have given the degree, they're asking you to convert it into radians.
Got it. So converting 120 degrees to radians, that'll just be 2 pi over 3, and converting 9 pi over 8 from radians to degrees would just basically be will be 405.
Yes. Now,
Oh wait, sorry, no, that's
1 minute.
9 pi. Sorry,
9.
that's 9 pi over 8. Sorry,
Yes,
then it'll be
9.
202.5. Sorry, I thought it said I thought that was reading something else. Sorry.
Okay, okay, no problem. Okay, so for each and every degree, they have given the radians measure here. Okay,
Mm-hmm.
okay. Now, what are applications of angles? Okay, so for a circle of radius r, a central angle theta will intercept an arc length. Okay, s is equals to r theta. Okay, the theta you call it to be the measure in radians. Okay, now if I'm going to have r is equal to 1 and s is theta, the radian measure of theta will be equals to the arc length actually. Fine.
Mm-hmm.
So how we will find when they are giving a linear speed, they are asking you to find the linear speed. If s is the length of the arc and t is the time, okay, the linear speed formula is arc length over time, that is s over t. This is the formula you need to find the linear speed of a particle when they are in terms of angles. Okay, in a coordinate plane they are given. They are asking you to find the angular speed, means the formula is central angle divided by the time. Okay, linear speed is arc length divided by the time. Angular speed is central angle divided by the time. Okay, yes, Josh?
Yeah,
Just make a note of these formulas. So when the
I am.
problem comes, it'll be. Yeah, yeah, yes, sure.
Okay, yeah.
Yeah. Okay. Now let's go to the next one. So you can just try this one and see. A 6-inch diameter gear makes 2.5 revolutions per second. Find the angular speed of the gear in radians per second. Just try this and check whether you are getting this answer.
Okay,
Now they are
so
asking the
it's
angular
6 inch
speed.
yeah, so it's 6 inch diameter, which means that it's gonna have a radius of 3,
Yes, right.
and it makes 2.5 revolutions per second. So that basically means it's doing that around 5 radians per second. Yeah, because
Yes. 5 pi radians per second.
yeah.
Yes, right. Okay, next. Now, coming to a sector. This, all these definitions in circles itself you have read, just a review. What is a sector of a circle? Region bounded by 2 radii of the circle. So, and the intercepted arc. So, if I'm going to have a circle, and this is nothing but a radii, right? From the center to this. And this is also becomes a radii. So this one becomes the sector of a circle. The region bounded by 2 radii of the circle and the intercepted arc. Okay. So for any circle of radius r, area formula for this area of a sector of a circle is nothing but a equals to 1 over 2 times r square times theta. This formula is very important because when you go to integral calculus or something, it is very useful for you. Okay. This formula we will be using for integrating the given, they will give a curve or any function they will give you and they will ask you to integrate or differentiate, even for differentiation. Okay. So this formula is very important, area of a sector of a circle. That is 1 over 2 times r square theta. Okay. Yes. Let me take the next one. So I'll give the introduction for 4.2 also, then we will move on to the book exercises. Okay, so it will be
Okay.
yeah. So now the first, coming to the definition of an unit circle. Okay, so what is a unit circle? Just 1 second, I'll download this so that. One second, Josh. I'm just opening it. Yes. Okay, what is a unit circle? As I told you, a circle of radius 1, the center must be at the origin and given by the equation x squared plus y squared equal to 1, okay, it's called as a unit circle, okay? You understand? So unit circle means it's with center at the origin, radius 1, and with the equation x squared plus y, general equation of a circle is x squared plus y squared equal to r squared. Since your radius is 1 here, we are just replacing with that. Okay, yes. Next, coming to the important definition which we will be using here is a period. What is a period? A function f is periodic if there is going to exist a positive real number c, okay, in between whatever period, the interval they have given, okay, such that f of t plus c, that means you are going to, a function is there, you are going to give a small change to that function, f of t plus c will be equal to t for all t in that particular domain, okay. The smallest number c for which f is periodic is called as a period of f.
Can I
Okay,
just read that for a second? Sorry.
yeah. Shall I repeat it again?
Yeah, it's okay.
Yeah, definitely. So f, a function f, you are going to say when it will be periodic, you are going to have a function, okay. In that, if you are going to give a small, you are going to take a small number c in that. It is not going to change anything to your function, okay. But if I am going to give a small addition or something to the function, okay, that is f of t plus c if I am finding, and that is also equal to f of t means, okay, for all the domain in that particular thing, then the smallest number c for which f is periodic. Periodic means the f of t plus c equal to f of c. Okay. The change, originally it was, suppose I'll take f of x, the circle to be some value. I will take here, they have given any value here. Suppose, one second. Okay, I will take my own. Suppose if I'm saying f of x equal to x, for example, I'm saying, okay, x or x squared, I will take. Okay. Now, if I'm going to say x plus 2, so what will happen? It's nothing but it will be x squared, x plus 2 the whole square, right? But it will, the value after substituting or something, f of x and f of x plus 2 will be the same. It is equal.
Yeah.
That's called as a periodic. The number, whatever you have added to that, which is making the function periodic, after changing also it is periodic, that's called as a period of f. Okay, that is,
Okay.
here the period will be 2 for us. That small number which doesn't make any changes in the function after adding to the given function also, you call it to be the period. Okay,
Does it usually represent an entire revolution, or can it be smaller?
it can be no, not a full revolution, it can be a smaller. Okay.
Okay.
Yeah. Now, next one. As the real number line is wrapped around the unit circle, each real number t corresponds to this point x comma y on the circle. Okay. So the real number 2 pi corresponds to the point 1 comma 0. Okay. You understand? Now, each number, real number t also corresponds to a central angle theta. This we have seen already, whose radian measure will be t. Okay. Now, with this interruption, the arc length formula, this is the formula for calculating the arc length. Okay. S is equals to r times theta with radius always equals to 1. Okay. Indicate what is that meaning? The real number t is the length of the arc intercepted by the angle theta given in the radius. Okay. Yes, Josh, you understood?
Yes.
Next, coming to your trigonometric functions. Okay. Obviously, when we are dealing with a unit circle, we are in a need of using the trigonometric functions. Okay. So the coordinate of x and y are two functions of the real variable t. Okay. It will have a 6 trigonometric functions of t. Okay. Sine, we will have it as sine, cosine, you know all these things, tangent, cosecant, secant, and cotangent. Okay, these are the 6 trigonometric functions we are need in or for defining a unit circle. Okay, so now I'm going to take, let t be a real number, x comma y be the point on a unit circle corresponding to t. Okay, now we are going to complete the following definitions of the trigonometric functions here. Sine t equals to y. This I hope you have studied in your lower grades when they are describing the trigonometric function. You remember? One second. If not, I'll tell you.
No, I know that sine is basically equal to let's just say x.
That you
Cosine is equal
will,
to y.
yes,
Tangent is basically equal to y over x.
yes, because it is becoming, we are
Or sorry,
using
x
the
over y.
Pythagoras theorem.
Sorry.
Yes, Pythagoras
Yeah.
theorem there. It's a right angle triangle, 0, 0, 1, 0, the same type. Okay, good. Now, the cosecant function will be the reciprocal of the sine, and cotangent will be the reciprocal of tangent, and secant function will be the cosine function. Okay. Now, this is the tablet form we will be using. When t is 0, your x will be 1 and y will be 0. Okay. Fine, that x comma y coordinates they are talking about. Okay. When it is 45-degree, okay, the value will be square root of 2 by 2. You remember? It
Mm-hmm.
is cosine of sine and cosine. We are just talking
Yeah.
about sine and cosine. Okay. Then sine 0 is 0, cosine of 0 is 1. Sorry, cosine of 90. Yeah. Then sine, cosine, like that. All the values corresponding to that. Okay. Now, then you are going to have it for pi by 6, pi by 3, pi by 2, what all the values they have shown here. Yes, George, you understand?
Mm-hmm.
This I showed it in the unit circle. They are just showing it separately. Okay. Yes. Now, find the following. Cosine of pi by 3. Can you
So
find it?
cosine of pi by 3 could just basically be cosine of 60, and cosine of 60 is also just 1/2.
Yes, right.
Tangent of 3 pi over 4, that's basically also the same thing as minus tangent of, sorry, would it also be the same thing as minus tangent of pi over 4, so 135?
Okay, so
Then will that
negative.
just be minus 1?
Yes, right. Okay.
And then cosecant of 7 pi over 6, that's basically equivalent to 210, and cosecant of 210, I don't exactly know that one. Would it be just
Actually,
negative?
initially, when you are going to have the unit circle, we know only the values of sine and cosine. Okay.
Yeah,
So,
so oh wait, quick question then. So cosecant, right? Basically,
mm,
so it's 7 pi over 2, and that's also going to be 7 pi over 2, and that's also the same thing as negative pi over 6, and that also is negative 30. So then that would also be sine of 30, and that would just be 1/2. And since it's cosecant, you reverse them, so that'll be 2 over 1, and since the negative would be negative 2, right?
yes, obviously, good. Okay.
Okay.
Next, coming to your domain and period of sine and cosine. Okay. So the sine function domain will be the set of all real numbers, and the range will be from -1 to 1. As we have seen the unit circle, it starts with the 0 and ends with this side, 180 degrees. So -1 to 1. Okay. This is for the sine function. You can make the domain and range. Okay. And for the cosine function, again, the domain and range will be set of all real numbers, and the range will be -1, 1. Okay. Period of the sine function will be 2 pi, and cosine function is also 2 pi. Okay. And which trigonometric functions are even function? Cosine and secant will be even functions. Okay. That means you will have your f of x will be equal to yeah, negative x. Negative f of x will be equal to negative f of x will become odd functions. Okay. Got it, George? Yes.
Mm-hmm.
So then what are the odd functions? Sine, cosecant, tangent, and cotangent will be odd functions. Okay. Now, evaluate sine 31 pi upon 6. So here you will be
That's
evaluating.
basically the same. Oh, sorry.
Yeah.
That's basically
Yes,
the
you
same
can.
thing as 5 Give me a sec.
Mm.
Sorry.
Yeah, yeah, yeah.
Okay. So that basically reduces to pi. Sorry. That basically is the same thing as 7 pi over 6, and 7 pi over 6 will be 210 in this case, and like I
Mm.
said it'll just be negative 1/2.
Yes, right. Okay, and using the calculator, this is part is easy, tangent of 4 pi by 3 and cosine of 3. Okay.
Yeah. So tangent of 4 pi by 3 would just basically be 240 in this case.
Yes, right.
And yeah, 240 in this case, and cosine of 3. So two. Okay, got it.
Yes. Okay. Next one. Okay. Yeah. Okay. Now
So
I
mind if we
will.
do some problems now? It's okay.
Yes. Yes. Obviously. 1 second.